Welcome to the Podlets podcast.
Good afternoon, everybody, and welcome to the Podlets podcast. My name's Duffy, and I'm back with you this week. We also have Josh and Carlicia, and a new member of our cast, Patrick Barker.
Hey, I'm Patrick. I'm a upstream contributor to Kubernetes. I do a lot of stuff around auditing.
And super glad to be here. What are we going to talk about today?
This week, we're going to talk about some of the building blocks of a cloud-native application. This week, we're going to kind of focus on contracts and how APIs kind of help us, and why they're important to the cloud-native ecosystem.
Right on. Yeah, and this is episode number 3.
So I guess we should kind of, usually with these episodes, we start talking about the problem first, and then we kind of dig into, into like why this particular solution, something like a contract or an API, is important. And so to kind of kick that off, let's talk about maybe this idea of API first development and like why that's important. And I know that Josh and Patrick both have, and Carlicia have all done some very interesting work in this space as far as like developing your applications with that kind of a model in mind.
I think the concept of doing something first just emphasizes its importance and the importance of developing to a contract.
Yeah, it's critical to build API-centric. When you don't build API-centric, most commonly you'll see across the ecosystem people building UI-centric. It's very tempting to do this sort of thing because UIs are visually enticing and they're kind of eye candy. But when you don't build API-centric and you go that direction, you kind of miss the majority of use cases down the line, which are often around an SDK, those ended up being more often than not the flows that are the most useful to people, but they're kind of hardest to see at the beginning. So I think going and saying, we're building a product API first is really saying, we understand that this is going to happen in the future and we're making this a principle early. We're going to enforce these patterns early so that we develop a complete product that can be used in many fashions.
Yeah, definitely. I've seen some of that in the past as well, working for a company called Nicira, which is a network virtualization company. We were really focused on providing an API that would be between you and your network infrastructure. And I remember that being really critical, that we define effectively what would be in the entire public API for that product out in front. And then later on, we figured out, obviously to learn the semantics of this, or to be able to like build a mental model around what that API might be, that's where the UI piece comes in, right? And so that was an interesting experiment, and like we ended up actually kind of creating what was an early version of kind of like the Swagger UI, in which you basically had a UI that would allow you to explore and introspect and play with all of those different API objects. But it wasn't a UI in the sense that, it had a constrained user story that was trying to be defined, end to end. And so that was my first experience where I was working with a product that had an API first model.
Yeah, I think so. I'll jump back in now. I had to warm up my brain and think about why do we build APIs to begin with before I could think why API first is of any benefit and what the benefits are. And I actually looked up something today, and it's this Jeff Bezos mandate. I had seen this before, right? And so, why do we build APIs? Mainly, we want to automate. API, what you're talking about is data transfer, right? Is taking data from over here and sending it over there. Or you're making it available so somebody can fetch it. And so it's communication. And why do we build API? To make it easier to do that. So you can automate, you can expose it, you can add some security. You can gate it with some security, right? Authentication, all of those things. And with the ever-increasing amount of data, this becomes more and more relevant. And I think when, like Patrick was saying, when you do API first, you absolutely focusing on making it all of those characteristics a priority, making that work well. And then if you want to make it pretty, okay, you can take that data and transform it in some other way to make your presentation pretty, to display on a mobile device or whatever.
Yeah, I think another thing with kind of inserting the API design up front in the software development lifecycle, at least in my experience, has been it allows you to sort of gather feedback from who your consumers will be early on before you worry about the intricacies of all the implementation details, right? So kind of like, I guess with Nicera's instant stuff, yeah, I wondered when you all made that contract, were you kind of pushing out a Swagger UI or just general, API documentation before you had actually implemented the underlying pieces, or did that all happen together?
I'd say it was an API first. It was absolutely, we didn't build out the UI until after the fact. So even to the point where we would define a new object in that API, like a distributed logical router, for example, before we would actually define that API first, and we would have test plans for it and all of that stuff, and then we would surface it in the UI part of it. And that's a great point. Like, it is certainly easier. I mean, I don't know. I wouldn't say easier. I will say that it is probably to your benefit in the long run to define what all of the things that you're going to be concerned with are out front. And if you could do that in a contractual basis, whether that contract is represented by an API or whether that contract is represented by a data model, it's critical that you have some way of actually defining exactly what that is, so that you can also support things like versioning and being able to actually modify that contract as you move forward.
I think another important piece here too is when you just look at the data model and the concepts and you focus on those first, you have a tendency to more decompose the problem, right? You start to look at things and you break it down better into individual pieces that combine better, and you end up with more use cases and you end up with a more usable API.
That's a good point. Yeah, I think one of the key parts of this contract conversation is kind of like what you're trying to solve. And it's always important, And I think that when I talk about API first development, it is totally kind of in line with that. You have to kind of think about what all the use cases are, and if you're trying to develop a contract that might satisfy multiple use cases, then you get this great benefit of thinking of it as you can kind of collapse a lot of the functionality down into a more composable API rather than having to solve each individual use case in a kind of a myopic way.
Yeah, it's the concept of reusability. You mainly having now the ability of making things reusable, composable, reusable, right?
And I think we've probably all seen UIs that get stuck in exactly that pattern, to Patrick's point. They try to solve the user story for the UI, and then on the back end, you're like, why do we have two different data models for the same object? It doesn't make sense. We've definitely seen that before.
Yeah, I've seen it more times than not. I think it takes a lot of discipline to really build a UI or an API, first, and to focus on those pieces first. It's so tempting to go right to the UI because you get these immediate results and everyone's like, oh, yay. And you really kind of need to bring that back. And and just it takes discipline to focus on the concepts first, but it's just so important to do.
I guess it depends on what you are doing too. I can see all kinds of benefits for any kind of approach. But I guess one thing to highlight is that the different ways of doing it. You can do a UI first, presentation first. You can do a API first, and you can do a model first, so those are three different ways to approach the design. And then you have to think, well, what I'm saying is you shouldn't do one just because you don't know how to do the others. You should really look into what will serve you better.
Yep.
Yeah, so with a lot of this talk about APIs and contracts, obviously in software, there's kind of many levels of contracts we potentially work on, right? There's the higher level potential UI stuff, and sometimes there's the lower level pieces with code. So perhaps if you all think it's a good idea, we could start with talking about what we consider to be an API in the cloud native space and what we're referring to.
That sounds great.
Cool. So a lot of the APIs we've described so far, if I heard everyone correctly, they sounded like they were more so APIs describing perhaps a web service of sorts. Is that fair, or?
Yeah, that's actually, I mean, that is an interesting point to bring up. So I'm definitely describing kind of the consumption model of a particular service. I'm referring to that contract as, as an infrastructure guy, I want to be able to consume an API that would allow me to model or create infrastructure. And so I'm thinking of it from that perspective. I'm very much, I mean, if AWS didn't have an API, I probably wouldn't have adopted it. Like the UI is not enough to do this job. You know what I mean? Like I need something that I can tie to better abstractions, things like Terraform and stuff like that. So I'm definitely kind of picturing it from that perspective. But I will add one other interesting point to this, which is that, in some cases, to Josh's point, like these things are broken up into public and private APIs. And that might be kind of interesting to dig into, like why you would model it that way. Because I mean, there are certainly different interactions between composed services that you're going to have to solve for, and so this is an interesting point.
Let's hold that thought for a second. So we acknowledging that there are public and private APIs, and we can talk about why do services provide that? Why do services work with that? And other layers of other flavors of APIs are also. You can have, for example, a web service type of API, and you can have a command line API, right? And you can have a CLI on top of a web service API, which is the case, like comes to mind, Kubernetes. Mm-hmm. But they have different shapes and different flavors, even though they are accessing pretty much the same functionality. Of course, they have different purposes, and you have the CLI. And another one yet is the library. So the CLI, in this case, the CLI calls the library, which calls the web service API. But like Duffy is saying, it's critical sometimes to be able to have these different entry points, because each one has its different advantages. Like a lot of times it's way faster to do things on the command line than it is to do it, to be a UI interface on the web that would access that web API, which basically you do want to have either UI interface or a CLI interface over that, because you're humans.
What's interesting about Kubernetes too, and what I think they kind of introduced, and someone could correct me if I'm wrong, but is this kind of concept of a core generative type. And in Kubernetes, that ends up being these Go structs. And from the Go struct, you're generating out the web API and the CLI and the SDK. And they all just come from this one place. It's all code gen out of that. And Kubernetes is really the first place I've seen do that, but it's a really impressive model because you end up with this nice congruence across all your interfaces, and it just makes the product really grokkable, if you will, that you can understand the concepts better because everywhere you go, you end up with the same things and you're interacting with them in the same way.
This is kind of defining that sort of the type interface that Kubernetes relates to, right? Where you're going.
Yeah. And I mean, obviously Kubernetes is incredibly declarative, and we could talk a bit about declarative versus imperative. Kubernetes is almost entirely, declarative. So you end up with kind of a nice, neat declarative model, which, goes out to YAML, and you end up with a pretty clean interface into it.
Yeah. I also think we should back up just for a second and kind of talk about so if we're going to talk about just the API as it could be consumed by other things like this, then we're I think we're kind of talking a little bit about kind of a forward-facing API. And this is one of those things that I think Kubernetes does differently than pretty much any other model that I've seen. In Kubernetes, there are no hidden APIs. There's no private API. everything is exposed all the time, which is fascinating because it means that the contract has to be solid for every consumer, not just the ones that are public, but also any private, anything that's built on the back end of Kubernetes, the kubelet, controller manager. All of these pieces are going to be accessing the very same API that the user does. And I've never seen another application built this way. In most applications, what I see is actually that they might define an API between particular services, and you might have a contract between those particular services, because this is literally, to Carlicia's point, in most of the models that I've seen APIs or contracts written, this is about how I get data or consume data or interact with data between two services. And so there might be a contract between that service and all of its consumers, rather than between the core service and all of the consumers. And it's pretty interesting stuff.
I think that's an interesting point. Yeah. And like you said, Kubernetes is the first thing I've seen that does that. I'm building an API right now, and there's a strong push to have internal APIs for it. But we're building on top of a Kubernetes product, and it's so interesting how they've been able to do that, where literally every API is public, and it works well. There really aren't issues with it, and I think it actually creates a better understanding of the underlying system, and more people can probably contribute because of that. So really interesting on there.
And on that front, I hope this is a good segue, but I think it'd be really interesting to talk about that point you made, Patrick, around declarative versus imperative, and how the API we're discussing right now with Kubernetes in particular is almost entirely declarative. So could you maybe expand on that a bit and compare the two?
Yeah, and I think it's an interesting thing that Kubernetes has really brought to the forefront. I don't know if they'd be the first one. Another notable declarative API would be Terraform, right? But this notion of you just declare state within a file in some capacity, and you just apply that up to a server, and then that state is acted on by a controller, and it brings that state to fruition. That's almost indicative of Kubernetes at this point. I think it's so ingrained into the product, and it's one of the first things to kind of do that it's almost what you think of when you think of Kubernetes. And with the advent of CRDs and whatnot, that's now able to be extended out to really any use case you would have that would fit this declarative pattern of just declaring state, which it turns out there's a ton of use cases, and that's incredibly useful. But now they're kind of looking at, in core Kubernetes, could we add imperative functionality on top of the declarative resources, which is interesting too. So they're looking at that for V2 now, because there are limitations, right? Like there's some things that just don't fit into a declarative pattern perfectly that would fit just the standard, REST verbs. And you end up with some weird edges there. So as they're going towards V2, they're starting to look at, could we mix imperative and declarative, which is an even maybe more interesting idea if you could do that right.
Can you give an example of that, Patrick? Like in the Kubernetes world, what would that look like? Like a use case for that?
Mixing the two? Yeah. Say you have an object that just represents something, we'll call it foo, and you have a YAML file, and you're declaring foo to be some sort of thing. You can apply that file, and then now that state exists within the system, and things notice that state have changed, and they're acting on that state. But there are times when you might want that foo to have another action, right? Besides just applying state, you may want it to have some sort of capability on top of applying that state. There are quite a few use cases that come in where that turns into a thing. So it's something to explore. It's a bit of a, Pandora's box, if you will, because, where does that end? Kubernetes is kind of nice that it does enforce constraints at this core level, and it produces these really kind of deep patterns within the system that people find kind of easy to understand, at least at a high level. Granted, you go deep into it, it gets highly complex, but enforcing like namespaces, as this concept of just a flat namespace with declarative resources within it, and then declarative resources themselves just being confined to the standard REST verbs, is a model that people, I think, understand well. And I think this is part of the success of Kubernetes is just that people can get their heads around that model, and it's also just incredibly useful, right?
I think that's right. Another, to add a little more color to this, I think another way to think about this is like you probably see articles out there that kind of describe sort of the RESTful model, and talking about whether REST can be transactional. So let's talk about a little bit about what that means. So like a naive implementation of an API-like pattern or an interface pattern might be that the client sends information to the server and that the server locks that client connection until it is able to return the result, whatever that result is. Think of this, in some ways, this is very much like a database, right? If as a client of a database, I want to insert a row into a database, the database will lock that row, it will lock my connection, it will insert that row, and it will return success. And in this way, it's synchronous, right? It's not trying to just accept the change. It wants to make sure that it returns to me. I have persisted that change to the database before letting go of the connection. This pattern is probably one of the most common patterns in interfaces in the world. Like, it is way super common, but it's very different than the RESTful pattern or some of the implementations of a RESTful pattern, in which what we say, especially in this declarative model, right? In a declarative model, the contract is basically, I'm going to describe a thing, and you're going to tell me when you understand the thing I want to describe. And it's asynchronous. So for example, if I were interacting with Kubernetes and I said, kubektl create a pod, I would provide the information necessary to define that pod declaratively. And I would get back from the API server 200, okay, pod has been accepted. It doesn't mean it's been created. It means it's been accepted as an object and persisted to disk. Now, to understand from a declarative perspective where I am in the lifecycle of managing that pod object, I have to query that API again. Hey, this pod that I asked you to make, are you done making it? And how does this work between and where are you in that cycle of creating that thing, right? And this is where, like within Kubernetes, we have the idea of a spec, which defines all of the bits that are declaratively described, and we have the idea of a status, which describes what we've been up to around that declarative object and whether we've actually successfully created it or not. I would argue fundamentally that from a cloud native perspective, that declarative model is critical to our success, because it allows us to scale. It allows us to provide an asynchronous API around those objects that we're trying to interact with. And it really changes the game as far as like how we go about implementing those inputs, right? Like, and it's pretty interesting stuff.
Yeah, this is so interesting. It was definitely a mind bender for me when I started developing against Kubernetes, because it was like, what do you mean you returned the 200 okay and the thing is not created yet? When is it going to be created? It's like, what? Totally. I was so not, I mean, it's not hard to understand, but I was so not used to that model. But I think it gives us a lot of control. So it's very interesting in that way. And I think you might be right, Afi, that it might be critical to the success of cloud native apps, because it's almost like the way I'm thinking about it right now, just having heard you, is almost like with other models, let's say you're working with a database in a transactional system, you're sending the data has to be inserted, and that system decides to retry or not. And once the transaction is complete, we get a result back. With a Kubernetes model or a cloud native model, I don't know if both are proper things to say. The control is with us. So we send the request, and Kubernetes is going to do it. If we're talking about Kubernetes, right? Kubernetes is going to do its thing, which allows us to move on too, which is great, right? And then then I can check for the result when I want to check, And then I can decide what to do with the results when I want to do anything with it, if at all. So I think it gives us a lot more control as developers.
I agree. And I think another thing that has kind of stuck in my head around this model, whether it be declarative or imperative, is that I think that, Golang itself has actually really enabled us to adopt kind of that asynchronous model around things in that it has, first class, the threads are first class, right? Like you can build a channel to handle each individual request, that you're not in this world where all of the, all transactions have to stop until this one is complete, and then we'll take the next one out of the queue and do that one. We're no longer in that kind of a queue model. We can actually handle these things in parallel quite a bit more, and it makes you think differently when you're developing software to some degree.
Yeah,
I think it's it's great too that you can check this stuff into a repo, right? And the advent of GitOps, is almost parallels, the advent of Kubernetes and Terraform, and that you can now have this state that's source controlled, and then you just apply it to this system, and it kind of understands what to do with it and how to put all the pieces together that you gave it, which is a super powerful model.
There's another point to that whole asynchronous model, like the idea of the API that has a declarative or an imperative model. And this is an idea in distributed systems that is referred to as like edge triggering or level triggering. I definitely recommend looking up this idea. There's a great article on it and on HackerNoon. And what they highlight is that from the pure abstract perspective, there's probably no difference between edge and level triggering. But when you get down to the details, especially with distributed systems or cloud native architectures, you have to take into account the fact that there's a whole bunch of disruption between your services pretty much all the time. And this is the challenge of distributed systems in general, right? Wherein you're defining a bunch of unique individual systems that need to interact, and they're going to rely on an unreliable network, and they're going to rely on unreliable DNS, and they're going to rely on all kinds of things that are going to jump in the way of between these two communication models. And the question becomes like, how do you build a system that can be resilient to those interruptions, right? And the asynchronous model absolutely puts you in that place, right? Where if you're in a situation wherein you say, create me a pod, and that pod object is persisted, and now you can have something else do the work that will reconcile that declared state with the actual state until it works. It'll just keep trying and trying and trying until it works. Whereas, like in other models, you basically say, okay, well, what work do I have to do right now? And I have to focus on doing this work until it stops. What happens if the process itself dies? What happens if any of the interruptions that we talked about happened, right? Like another good example of this is sort of like the kind of the Kafka model versus something like a watch on etcd, right? In Kafka, you have these events that you're watching for, and if you weren't paying attention when that event went by, you didn't get that event. It's not still there. It's gone now. Whereas like with etcd and models like that, what you're saying is I need to reconcile my expected state of the world with what the desired state is. And so I'm no longer looking for events. I'm looking for a list of work that has to be that I have to reconcile to, which is a very different model for these sorts of things.
Yeah, and in Kubernetes, that becomes, the informer pattern, if you all don't know, which is basically, and at the core of the informer is just this concept of list and watch, where you're just watching for changes, but every so often you list as well in case you miss something. And I would argue that, that pattern is so much more powerful than the Kafka model you're discussing as well, because like you mentioned, if you miss an event in Kafka somehow, some way, it's very difficult to reconcile that state. And like you mentioned, like your entire system can go down in a level set system. You bring it back up, and because it's level set, everything just figures itself out, which is a lot nicer than your entire system going down in an edge-based system and trying to figure out how to put everything back together yourself, which is not a fun time if you've ever done it.
Exactly. Yeah, and so these are some of the patterns for contracts that we see, in the cloud native ecosystem, and some of the and I think it's really interesting to kind of talk about them. So did you have another point, Josh, around like APIs and stuff?
No, not in particular.
Okay. So I guess we can kind of get into like what some of the forms of these APIs talk about. Like we could talk about RESTful-based APIs versus gRPC-based APIs, or maybe even just interfaces back and forth between modular code, and like how that kind of help you architect things. One of the things I've had conversations with people around is we spend a lot of our time kind of conditioning our audience when in cloud native architecture to the idea that monoliths are bad, and they should never do them. And that's not necessarily true, right? Like, and I think it's definitely worth talking through like why we have these different opinions and like what they mean. When I hear that, when I have that conversation with customers, frequently a monolith makes sense because as long as you're able to build modularity into it, and you're being really clear about the interfaces back and forth between those functions, with the idea that if you have to actually scale traffic to or from this monolith, if the function that you're writing needs to be effectively externalized in such a way that it can handle an amount of work that will surpass what the entire monolith can handle, as long as you're really clear about the contract that you're defining between those functions, then later on, when it comes to time to externalize those functions and kind of embrace more of a microservices model, mainly due to traffic or load or any of the other concerns that kind of drive you toward a cloud native architecture, I think you're in a better spot. And this is definitely one of the points of that contract piece that I wanted to raise up.
That is a brilliant observation. I wonder, though, how hard is it for people to keep that in mind and follow that intention? Because if you have to break things into microservices because you have bottlenecks in your monolith, and maybe you have to redo the whole thing. Once you have the microservices, you have gone through the exercise of deciding, this goes here, this goes there, and once you have those separate, I don't want to say the word container, those modules, the separate modules, it's clear where things should go. But when you have a monolith, it's so easy to put things in a different place, in a place where they shouldn't be. It takes so much discipline, and if you're working on a team that's greater than 2, I don't know.
Yeah,
I think in theory what you said is brilliant, but in practice, I don't think. Have you seen it work?
I have seen it work, but I mean, like there are certain languages that kind of like lend themselves to these things. Like when you're writing Java services, or there are things where like it is easy to rapidly prototyping an application that has multiple functions, to be careful about those interfaces that you're writing. Like Go, because it's a strongly typed language, kind of forces you into this, right? Like there are some other things, there's some other languages that are out there that are kind of like really, that make it difficult to be sloppy about those interfaces. And I think that's inherently a good thing. But to your point, like, you look at some of the larger monoliths that are out there, it is very easy to fall into these patterns where instead of an asynchronous API or an asynchronous interface, you have just an A to B interface, and you're a synchronous interface in which you expect that I will be able to call this function, I'll put something in there, I'll get the result back. And that is a pattern for monoliths. Like that's how we do it in monoliths.
Sorry, so because you're saying that also made me think of the Conways Law. Right? Because when we separate things into microservices, I mean, and I'm not saying microservices is right for everything, for every team, for every company, but I'm just saying if you are going through that exercise of thinking, of separating things because you have bottlenecks, and maybe in the future you have to put them elsewhere, externalize them, like you said. If you think of the Conways Law, if you have a big team everybody working on the same monolith, that's when things are bound to end up in a place where they shouldn't be. And the point of microservices is not just to technically separate things, but to allow people to work separately, and that inter-team communication is going to be reflected in the software that they are building. But because they're forced to communicate and hopefully they do it well, the culture, right? That those microservices should be well designed. But if you have a monolith and people are just everyone working on the same product or project, it gets more confusing.
So Conway's Law, as an overview, is basically that an organization will build software laid out similar to the way that the organization itself is architected. So if everybody in the entire company is working on one thing and they're really focused on doing that one thing, you're going to build a monolith. If you have these groups that are disparate and are really focused on some subset of work and need to communicate with each other to do that thing, then you're going to build something similar, or maybe more capable as a microservice. I think that's a great point. Like, especially one of the things that about Heptio that I found so fascinating was that we were 100 people and we were everywhere, and so communication became a problem that absolutely had to be solved, or we wouldn't be able to move forward as a team. And so it was really, that's a very good point.
An observation that I had in my past life helping folks break apart Java monoliths. Sorry, there's a dog barking. Hopefully you can't hear it. Breaking apart Java monoliths was, but like you said, Duffy, like assume they had really good interfaces and contracts, right? And that made it a lot easier to find the breaking points for their APIs to pull those APIs out into a different type of API, right? They went from this programmatic API that was in the JVM where things were just intercommunicating to an API that was based on a web service. And an interesting observation I oftentimes found was that people didn't realize that they were moving complexity from within the app to the network space. And that oftentimes caused a lot of issues. So, and I'm not trying to down APIs because obviously we're trying to talk about the benefits of them, but it's an interesting balancing act. Oftentimes when you're working with how to decouple a monolith, I feel like you actually can go too far with it. And it can cause some serious issues.
I completely agree with that. Yeah. And I think that's kind of where we were headed, where I wanted to go with the idea of why we say that building a monolith is bad and what the challenges of breaking those monoliths up are later, right? But you're absolutely right. Like when you're going to introduce effectively the wild chaos that is a network between your services, or you're going to externalize functions, and which means that you have to care a lot more about where you store state, because that state is no longer shared across all of the things. You have to. It means that you have to just be really super careful about how you're modeling that, and because if you get to the point where this software that you've built that is a monolith is wildly successful, and all of its consumers are network based, you're gonna have to kind of come around, and so yeah. I think that's pretty critical. Now, I mean, on that point of contracts, I think another thing that we haven't really talked on so much is we all agree that maybe an API for the consumer model is important. We've talked a little bit about whether private APIs or public APIs make sense. We've kind of described some differences between, or one of the wacky things that Kubernetes does, which is that there are no private APIs. It's all totally exposed all the time. I'm sure that all of us have seen way more examples of things that do have a private API, mainly because perhaps those services are chained. Service A always talks to Service B. Service B has an API that may be a private API you're never going to expose to your external customers, only to Service A or to consumers of that internal API. One of the other things that we should talk about is when you're starting to think about these contracts, one of the biggest and most important bits is how you handle the lifecycle of those APIs. So as they change, right? As I add new features or functionality, or as I deprecate old features or functionality, what are my concerns as it relates to this contract?
Tell me and take my money, Duffy.
Say again?
Tell me and take my money.
I wish there was a perfect answer, but I'm pretty convinced that there are no perfect answers.
Yeah, I spent a lot of time in this space recently, and I researched it for a month or so. And honestly, like you're saying, there are no perfect answers to trying to version an API. Every single one of them has horrible potential consequences to it. The approach Kubernetes took is API evolution, where basically all versions of the API have to be backwards compatible. And they basically all translate to what is an internal type in Kubernetes, and everything has to be translatable back to that. This is nice for reasons. It is also very difficult to deal with at times, because if you add things to the API, you can't really ever remove them without some sort of a massive amount of deprecation effort, basically monitoring the usage of that API specifically and then somehow deprecating it. It's incredibly challenging. So,
yeah. I'm actually really, I've got my popcorn ready for, like, I think it's like 116, in which we actually finally turn off a lot of the deprecated APIs that Kubernetes had. So a lot of the stuff that has been moved for some number of versions off to different spaces. For example, deployments used to be in extensions and now they're in apps. You have a lot of these things. Some of the older APIs are going to be turned off by default in 116. And I'm like, really interested to see how this plays out, from kind of a chaos level perspective. But yeah, you're right. It's tough, having that backwards compatibility definitely means that the contract is still viable for your customers, regardless of how old their client, how old that client side looks like. But I mean, this is kind of a fingernail problem, right? You're going to be in a situation where you're going to be holding those translations to that stored object for how many generations before you're able to finally get rid of some of those old APIs that you have obviously moved on from.
Yeah, deprecating an endpoint is not trivial at all. And ideally, like Patrick was saying, you would be able to monitor the usage of that endpoint and see, as you intend to deprecate it, if the usage is going lower, and if there is anything you can do to accelerate that. So, which actually made me think of a question I have for you guys, because I don't know the answer to this. Do we have access to the endpoint usage, the consumption rate of Kubernetes endpoints by any of the cloud service providers? Okay, it would be nice if we did.
Yeah, there'd be no way for us to get that information, right? Like the thing about Kubernetes is it's something that you're going to run on your own infrastructure, and there's no phone home thing like that.
Yeah, but the cloud providers could do that and provide that as a nice service to the community.
They could. That's a very good point. Yeah, EC2 and GKE could expose, some of the statistics around those API endpoints. It would be interesting.
I think the model right now is they just kind of ping the community and say they're deprecating it, and if a bunch of people scream, they don't. Yeah. I mean, that's the only way to really know right now.
The squeaky wheels get the grease, kind of.
Yeah, I mean, that's how it turns out.
Yeah.
And regarding versioning, taking it out of Kubernetes for a second, I also think this is one of the challenges with microservice architectures, right? Because now you have the ability to independently deploy a service outside of the whole monolith. And if you happen to break something that perhaps contractually you said you would and people just didn't pay attention, or you accidentally broke not knowing, it can cause a lot of rift in a system. So versioning becomes a new concern because you're no longer deploying a massive system, you're deploying bits of it and perhaps versioning them and releasing them at different times. So again, it's kind of that added complexity.
And then you have this, like, this set of versions talks to this set of versions. Now you have a matrix, and it's very complicated.
Well, yeah, and you do somewhat have a choice. Like, you can have each service independently versioned, or you could go with global versioning, where everything within V1 could talk to everything else within V1. But it's an interesting point around breakage, because frameworks like gRPC, they kind of give you tooling and they kind of enforce. Tools like gRPC kind of enforce you to where you cannot break the API through just kind of how the framework itself is built. And that's why you see gRPC in a lot of places where you see microservices, just because it helps keep the system stable.
Yeah, and I will call back to that one point again, which I think is actually one of the, to Josh's point, like if you're going to build multiple services and you're building an API between them, then that means that the communication path might be service A to service B, and service B to service A, and you're going to build a kind of this crazy mesh in which you have to define an API at each of these points to allow for that consumption or for that interaction with data. And one of the big takeaways for me in studying kind of the cloud native ecosystem is that if you can define that API and that declarative state as kind of a central model to all of your services, then you can flip this model on its head. Instead of actually trying to define an API in front of a service, you can make that service a consumer of a centralized API. And now you have one contract to write and one contract to stand by, and all of those things that are going to do work are going to pull down from that central API and do the work and put back into that central API the result. Right? Meaning that you're flipping this model on its head. You're no longer locking to service B until service B can return a result to you. You're saying, service B, here's a queue or maybe a declarative state that I want you to accomplish. And when you're done accomplishing it, let me know and I will come back for the results, right? And you could let me know in an event stream. You can let me know by updating a status object that I'm monitoring. There's lots of different ways for you to let me know that service B is done doing the work. But it really makes you think about kind of the architecture of these distributed systems. And it's really one of the big highlights for me personally when I look at the way that that Kubernetes was architected, because there are no private APIs. Everything talks to the API server. Everything that's doing work, regardless of what data it's manipulating, what it's changing or modifying, it has to adhere to that central contract.
And that's an interesting point you brought up, is that Kubernetes in a way is almost a monolith in that everything passes through the API server, all the data lives in this central place, but you still kind of have this distributed nature to it with the controllers. So it's almost a mix of the patterns in some ways.
So yeah, I mean, thanks for the discussion, everybody. That was a tremendous talk on kind of contracts and APIs. I hope everybody got some real value out of it. And this is Duffy signing off. I'll see you next week.
This is great. Thank you.